Let's solve the question on the board. Calculate the potential difference across 45 ohm resistor. This is the 45 ohm resistor. Remember, in a series connection, each resistor has its own potential difference, and voltage or voltmeter is connected across two ends. So here is the voltmeter. So we want to calculate the reading of the voltmeter. For us to calculate this, we make use of Ohm's law, which says that current is equal to resistance. We have the value for resistance, which is 45. Then from the circuit, let's get the value for current. Looking at this circuit, this is the cell. Current flows in this direction, and the current flows directly to the ammeter. And the ammeter read 0.1 amp. We now have 0.1 times 45. 0.1 times 45 is equal to 4.5 volts. So the potential difference across 45 ohm resistor is equal to 4.5 volts. We now look at B. B says, calculate the resistance of R. This is R, so we're asked to find its value. We have three resistors here, and they are all in series. So what we are going to do, we'll find the effective resistance in the circuit. And we can find the effective resistance in this circuit using the formula V equal to IR. From here, we find the effective resistance in this circuit, which is R, knowing that the potential difference across this whole circuit is equal to 12 volts. And the current flowing in this circuit is equal to 0.1 amp. So here we are going to have R as equal to potential difference over current. Potential difference is 12. So here is 12 divided by 0.1. 0.1. And that will give us 120 ohms. So which means that the total resistance in this circuit is equal to 120 ohms. But we're asked to find the value of what? This resistance. Since it is a series connection, the total resistance in the circuit will be equal to R1 plus R2 plus R3, which means 120 is equal to, let's call this R1, R2, and R3. So here will be 15 plus R2 plus 45. We're going to have 120 equal to 60 plus R2. Okay, let me use here. 120 equal to 60 plus R2. 60 will cross the equality sign. We're going to have R2 is equal to 120 minus 60. And 120 minus 60 is equal to 60 ohms. So the value for R here is equal to 60 ohms. The next says, state what happens to the total resistance and current when the switch is closed. Remember, here is 60 ohms. If this switch is closed, current will flow down to this point, and down to this point, and down to this point. Because this switch is closed, all the current flowing through this circuit will now move in this direction. We call it a short circuit. A short circuit. Because resistance opposes the flow of current in a circuit. Because of that, no current flows through this resistor. So which means that the 60 ohm resistor is sound insignificant, telling us that the total resistance in this circuit, when we close this circuit, will be R will be 45 plus 15, and that will give us 60 ohms. So when we close the circuit, the resistance will decrease. And once resistance decreases, current will increase, because resistance opposes the flow of current in a circuit. So once there is a decrease in resistance, current will what? Increase. So if we close this circuit, we'll have 60 ohm resistance in this circuit. The flow of current will increase. If we open this circuit, we'll have 120 ohm resistance in this circuit, which means that current will decrease. Follow me for more physics content like this. Bye.